Hey math enthusiast, I'm here to go over the second part of section 4.2, which deals with congruent figures. The first theorem we come across is the third angles theorem. So this is dealing with two triangles, in which case we have angle A congruent to angle D and angle B congruent to angle E. Now the thing is, I know that both of these triangles, their angles must add up to 180 degrees. So let's say, for example, angle A measures 45 degrees. Then that means angle D must also measure 45 degrees. And let's say that angle B measures 70 degrees. So that means angle E must measure 70 degrees. So based on that, using the triangle sum theorem, I know that angle C must equal 65 degrees for the triangle to add up to 180. And angle F must equal 65 degrees for the same reason. So even though I wasn't initially told that angle C is congruent to angle F, I can mark them as being congruent because they're the third angles in these two triangles where I have two congruent angles. That's essentially what this third angles theorem is stating. So in this case, if I have two angles of one triangle that are congruent to two angles of another triangle, then the third angles are also congruent. So in example 5, I want to try to apply this third angles theorem. I'm looking to solve for the measure of angle D down in the bottom right. So first thing I notice is we have 71 for B. Angle A and angle D are actually congruent. They each have one arc in them. And then we have this 47 by angle E. So the first thing I want to do is apply my vertical angles. So if I have 47 on this angle on the right, that means that this angle on the left is also going to be 47 because they're vertical angles. Now let's just focus on that triangle on the left, triangle ABE. So I know those three angles together should add up to 180. We have 71, we have 47, and angle A, which I'm just going to call X. So together they should equal 180. So we end up with 118 plus X equals 180. And it looks like X equals 62. So I can go back and fill that in for angle A, and the thing is, since angle A has one arc and angle D has one arc, I know that they are congruent. So that means the measure of angle D is also going to be 62 degrees. And in this case, I could actually apply that third angles theorem to solve for angle C. Since I have 62 and 47 in one triangle, and 62 and 47 in the other triangle, that means that their third angles must be congruent. So the measure of angle C has to be 71 degrees. For the next example, they start off by telling me triangle ABC is congruent to RST. And I want to draw and label these figures to start. So we have two congruent triangles. I'll try to draw them so they appear about the same size. First one is ABC, and I want to label the next one so it kind of goes in the same order. A corresponds with R, B corresponds with S, and C corresponds with T. Next thing is the angles that they give me. A is 2x plus 5. S is x minus 15. And R is 55. Now, because my triangles are congruent, I know that A is congruent to R, angle B is congruent to angle S, and angle C is congruent to angle T. So I can actually put one arc here, two arcs here, two arcs here. So I can actually say that angle B is x minus 15 as well. And I can put 3 arcs in angle T and 3 arcs in angle C. So now I can easily see what goes with what. Well, I already pointed out that angle A and angle R are congruent, so that means their measurements are going to be equal. Well, that means that 2x plus 5 must equal 55. So now I can solve for x. It looks like I end up with 2x equals 50, so x equals 25. Now with x, I can go back and find the measure of my other angles. So if x is 25, that means that angle S is going to be 10, which means angle B is going to be 10. We already determined that A and R are the same, so angle A is actually 55 degrees. And now we have 2 out of 3 angles in my triangle. So we'll call this third angle Y, since we already used X earlier. So we have 10 plus 55 plus Y together equals 180. So we end up with 65 plus Y equals 180. And it looks like Y equals 115. So my last angle, angle T, and angle C are both 115 degrees. Last thing I want to do is classify my triangles. I know they're congruent, so they're both going to be classified the same way. It looks like none of the angles are the same, which tells me that none of the side lengths are the same. So it's definitely scalene. And one of the angles is greater than 90, which tells me it's going to be obtuse. Example number 7 is a little different. I'm not solving for any of the missing parts. What I'm trying to do is determine whether or not these triangles are congruent. And if they are, I want to write out a congruence statement. In order for these two triangles in figure A to be congruent, I need to show that we have 3 angles and 3 sides that correspond and are congruent. So let's take a look at the 2 triangles I'm comparing. I'm comparing this triangle up top, XYW, to the triangle below it, ZYW. So first let's focus on the angles. Easiest one to point out is X and Z. So I know that angle X is congruent to angle Z. Next one I notice is we have a right angle here. Once again, I can't just call that angle Y. I have to be more specific. So if I want to focus on this top right angle where the box was, I need to use 3 letters. So I'm going to call it X, Y, W. All right, notice I put Y in the middle because Y is the vertex of the angle. Well, that right angle is clearly going to match up to the one below it, and I'm going to call that angle ZYW. So the last angle I need to worry about is this one down by W. Once again, I need to use 3 letters to name it. One won't do because there's multiple angles coming from this one vertex. So that last angle, I'm going to call it XWY. All right, notice I have W in the middle because that's my vertex, and is congruent to this angle down below where I put the 2 ticks. So that one's going to be ZW, once again, is in the middle because that's the vertex, Y. Okay, so I've listed out my 3 angles. Let's focus on the 3 sides. So I have XY, which is congruent to ZY. Next one, we have 2 ticks here, so I have XW, which is congruent to ZW. And lastly, we have this side down the middle. Now, technically, it's the same side on each triangles, but if I were to split them apart, they're both going to be sharing that one side down the middle. So it must be congruent on both of them. So I can say that YW is congruent to YW. It seems very repetitive, all right, but this is an example of the reflexive property. And the last thing I want to note before we move to our congruent statement is these angles that were at W. I knew that they were going to be congruent because what I was using was that third angles theorem. All right, that helped me show that those last angles that weren't marked had to be congruent. Last thing I want to finish with is my congruent statement. So I want to show which two triangles are congruent. I'm going to start with the top one. We'll say XYW is congruent, and now I have to name the other triangle specifically so that it corresponds with the first name I picked out. So I started with X, which corresponds to Z, and obviously Y goes with Y and W goes with W in this case. So there's my final congruent statement. Now, for part B, it's easy to pick out the two triangles that I'm comparing. The angles aren't going to be hard because it looks like all the angles have the same measurement. So N, P, and M all have the same measurement. So that would be 180 divided by 3. All of these angles are going to measure 60 degrees. So it really doesn't matter which angles I match them up to in the other triangle because they're all going to be congruent to one another. So now let's focus on the three sides that I want to match up. So the thing is, we have one tick mark on NP, for example, if I start there. Well, the problem is when I move to the second triangle, each of these side lengths have 2 tick marks, which tells me that they are not the same length as NP with 1 tick mark. All right. Yes, they're all congruent to each other because they all have 2 tick marks, but the problem is I need them to correspond to my original triangle where I have NP. So in this case, none of the sides are going to be congruent to one another, which tells me that my triangles, if I tried to write out a congruent statement, it's not going to work here because my triangles are not congruent.